Oh, we haven't spent it again. She was so cool.
All right. Question 1. Now, I can't remember if we talked about this last week, but yeah, we are. I can display all day long. I can touch it all day long. Doesn't respond at all. Okay? So what they did last week didn't fix anything. All right? The limited that I could write on it that drew the lines everywhere, even that's gone. Okay? So when they tried to put the free trial on it, it didn't load. When they said they'd come back, they've yet to be back. So, and I've had to be Miss Love for 2 days, so I haven't even been able to try to go find them and say, hey, are you coming back? So, all we have is just limited amount of space on the whiteboard. So for people like Chris at the back who are zooming in on their phone, I guess continue to zoom in on your phone. So, 160 milliliters. Milliliters to liters. If you do not know this conversion, we're going to use this one so often in the gas laws. This one would be worth your time to memorize if you don't know it. What's bigger?
Set up right.
King Henry died by drinking chocolate milk. For those of you who have forgotten, liters sits on the baseline. Who's bigger, a liter or a milliliter?
Liter.
A liter. We put a 1 with a liter. 1, 2, 3 spaces. 3 spaces is 3 zeros and a 1. If you do not remember that one, like I said, it's well worth memorizing this one because you're going to use it a lot. So 160 divided by 1,000 is 0.16 liters. Number 2, what are we supposed to remember about centimeters cubed milliliters?
The same thing.
They're the exact same thing. If you want to put it in a chart, you can. For those of you who wanted to put it in a chart, it would have looked like this. 1, 1. If you want to put it in a chart, it's not necessary. They are the exact same thing. So you would have 5.34 milliliters. Okay? Number 3. Grams to moles. This one we've done many times over the last couple months.
To this day.
All right. We are bringing stoichiometry back towards the end of the unit. This week before break, for those of you who suck at stoichiometry, you should enjoy the first part of the unit because there's no stoichiometry. Okay? So we're going grams to moles. Grams goes at the bottom, moles goes at the top. What goes beside moles if there's no balanced equation? All right? All you have to remember is it or is it not diatomic? Is oxygen one of the 7 diatomics?
Yes.
Yes. So O2, what's the max of oxygen?
16.
32. All right, because oxygen is diatomic. So what do we get when we say 57.3 divided by 32? 1.79 moles. All right, and the last one, Celsius to Kelvin. What's the formula?
Oh,
K equals C plus 273. So Kelvin is what I want. I gave you 34 plus 273. So you're going to get what? 307 K. Issues with how to do any of that?
No, ma'am.
Okay? Are we okay with that? All right, you should be putting your openings on the chair. Hopefully, the stapler is going to leave Patricia and Karen and find its way around the room after we've done the openings so that you can staple your test papers together. Oh, the stapler's already left the room?
Yeah.
And headed around? Okay, so if you need to staple after you locate the stapler, staple. Since it's heading around the room. Just go find it and staple.
What are we stapling?
The test paper and the answer sheet have to be stapled together. That's the only thing I didn't get done before today. I got it graded, but I didn't get it stapled.
The staplers somewhere.
I still had a lot of room on this week.
Okay.
I got a 75.
It's we're getting ready Saturday and like from morning to like Robin knows I was up late. But like the mask that one. I remember that one. So if you want to come, I'll send you the address and everything.
All right, any more openings I'm waiting on? Hurry up, get them up here so we can move on. We don't have a lot of time today.
You want me to leave?
I'm going to send you out in a minute. All right, so let me say Nadia, Sarah Lynn, Linda, and there's one more. Here's my fourth one. Who didn't take the test? There are 4 of you. It's somewhere in the room. Sarah Lynn, Nadia, Linda, and there's a 4th one. Alejandra.
I think I need to go to the doctor and get diagnosed with short-term memory loss because we had just did
Hey, Des, on your way back, close the door. All right. If you look at your test papers, on the front where it says MC, that's just the number of multiple choice questions you missed. You can see that now that you have the answer key on your test. And I hope you stapled it to the back. I would almost venture to guess half of you stapled it to the front. Even though you've received countless papers back from me, and it's always stapled where? You should be looking at the papers. Now, on the 3 pages that have free response, the number circled in the middle of the paper is the number that you missed. If a 0 is circled, that means you missed none, because I grade them page by page. So I graded on the last page, then I graded the 5th page, then I graded the 4th page. If there's a number circled at the very bottom of the page on the front, that's just the total of the answers you missed overall on the 3 response pages. Okay? Now, you had 79 questions, so it's scored based on the number you got right out of 79. All right, so 79 would be the total. If you got 52 correct, that's how I graded it. 52 correct over 79 times 100, that's how I got your score. Okay, so obviously the more you got correct over 79, the higher your score. All right, so if you have questions, I will take a very small number. I'm not spending the better part of today talking about test questions. Given that,
You're only saying Wednesday.
you can do test corrections. All right? I have more days after the break.
No, but don't you just want to get it over? What does that say?
My week is pretty full right now. What?
What does that say? I can't even. Like that? Oh my
It says balance.
Oh, okay.
Imbalance
It was.
equation.
He missed it. I was very.
It says BAS. Balance.
Oh.
Is that right?
Yeah.
An X or minus, and then I just give you credit. I probably gave you credit if everything else is correct.
You just wrote valid.
I didn't take all
Is
four
this
things, everything else was right.
And he was like my
Yes.
favorite girl.
US 5-1. This road should be 6. So say 6. There's a total for the page.
Oh, you want to see the dumps? It's a lot. I think I did know you did it.
Yes.
You know how in like elementary school where they have like the bee in the
Yeah. What?
Okay, in that case, I can't tell today.
Why you
Anybody else? Question? That you just have to know. This week I will be here Wednesday. After break, I have more days. I'm sorry. This week is just really busy in my world. I'm sorry that I'm not at y'all's beck and call, but this week is just
I can come during.
I'm not at y'all's beck and call.
Can I come here fourth today?
No, you may not come during my other classes.
Why?
Because you can't. Absolutely not. I've just spent 2 planning periods being this love. No. The week that we're back, I have Tuesday and I have Thursday.
Is that your saying?
I might even have Monday if they don't schedule the department chair meeting on Monday.
So you're giving us for sure 3 potential days.
I will have Wednesday. If they don't schedule the department chair meeting, I will have Monday, Tuesday, and Thursday. I would give you Wednesday, but y'all aren't in school.
Oh, yeah. That's May 1st?
That would have been my first day, yeah.
Okay, so. Wait, Monday.
That gives you 4 opportunities.
Hold on. So that first week.
The first week we're back. If the department chair meeting is scheduled on Monday and I have to cancel, I will reschedule that day.
So.
Okay? But that's
Tuesday the 30th and Thursday the 2nd, you're staying definitely.
yes.
I'm writing it in my agenda, so it's set in stone and you can't change it.
If I have to cancel, I will reschedule those days so I don't cheat you out of the 4 days.
And I'm not writing it on Monday because it's iffy.
Well, unless they
And my
reschedule
agenda
it.
is neat.
If they don't cancel it or schedule it, and I haven't scheduled it right now, I'm still available. All right? So, those are the 4 days I have. But this week is just a little full in my world. So Wednesday is still open for y'all. Now, since there doesn't seem to be something you just have to know, has everyone stapled their answer sheet to the test? You have it if you wish to do test corrections.
No.
All right, where did the stapler go if you're a no?
It's up there.
All right, so come staple. And then hand me your test paper so we can let them back in and move on. Shouldn't take too long.
Yeah, we were both.
Yes, a little bit. I mean, not a lot.
It's gonna be bad.
Faith, did you hand me yours? Annabelle, did you hand me yours? Annabelle, did you hand me yours?
That's my favorite.
All right, did I get everybody? Let's end here.
It's long. Can I go get some water real quick?
Yeah, hurry up.
I am. I just did.
See if you can get out 9, not 10, because my parents already slept. They left really late. And I'm me and Grace. Grace Midbrain.
All right, find your notes. Let's talk gas laws.
Oh my God. I thought today was gonna be nice.
Today is gonna be nice. It's a beautiful day outside.
It is really. Day after fall. This wall. I'll organize them. So June, we're taking the exams in order, right? Monday. So Tuesday should be your exam. Before.
Grab my phone. So, it's either way, it's fine.
Move your haircut.
Alright, she just gave us a new name, so 7th should be the makeup day. So 7th should be makeup
That's the
day.
last day.
Okay, so that should be 4, 3, 2, 1.
We Callie only have to come Tuesday, Monday, and Tuesday.
That's the only one you have to take? That's pretty good.
I know, right? Because Wednesday is multimedia and yearbook. 4th is A-Push internship. And for multimedia, we're taking our exams early May, and then we're going to class.
There you go.
All right.
Alright. Now, I will add things to these notes, and I will try to tell you where to write them at. The only place I can write them is on the whiteboard. Okay? I can't write on the smartboard, so I can't. Well, I guess I can write on the TV with a marker, which I'm not going to do. So, huh?
That's a regular.
It's a regular whiteboard. This one's not the same. Huh?
You right? Oh, never mind. Forget it.
Now,
Miss Wall, wait a minute. Is this a whole nother unit?
a whole nother year. It's the gas loss. Okay?
Dang, every time I ask a question.
Now, this unit will last approximately a week and a half. So,
That's next Friday or the week.
at best, it will be the Friday after we come back. At earliest. Okay? We do not. Thursday is our last day.
I
of
sleep
sleep.
so good. I don't understand this one.
Now, if we don't finish the notes I want to finish by 12 o'clock, you get to watch last semester's video. Okay? I'm not teaching this stuff tomorrow. And y'all are getting really bad about socializing when I need to talk. Now, kinetic molecular theory, and we're going to abbreviate that KMT just so you don't have to keep writing that out. All right, is the idea that particles in a sample of matter are always in motion. Now, when I say in a sample of matter, what states do I mean? I mean solids, liquids, and gases. All right, which is probably what I have under the blind. I haven't looked at these this semester, but all right. All right. Probably on the next page, but right here. All right, so under that, write solids, liquids, and gases. If I have it on the next page, we will not write it twice.
You said write it where?
Right under where you have that line.
Are they supposed to be trying to fix that?
I hope. I'm gonna go try to see Mr. Pope in the morning, because I have a planning period back. They won't pay for the subscription to fix it until August.
Whack.
I mean,
So
like,
will they
you make
expect us to
sense,
do
like,
not broken?
I mean, I get their point, but like,
Yeah,
So-
how do you have to pay for the subscription?
$130.
No, you have to keep
Oh,
paying.
every year.
Every year. Oh, once a year, really. I mean, I think it was once a month.
Well, if it's gonna be one subscription, it's like really important.
And I'm willing to pay it myself. If I was the only one using the computer, I'd put it on my Mac and do it like Mr. Johnson does. But my room is used by someone else first period.
So you don't want to share it?
I'm not sharing my personal computer with a group of kids
Oh, it's
who use my computer and my smart board for Spirit.
I thought it was a software, so you need
The software has to be loaded on a computer.
Dang.
Right, but look, we can split.
Right, maybe they use a, whatever it's called, whiteboard, and then you use this when you come in.
So there's the problem.
Right.
Either way, teachers.
Alright, so when we talk about the three types of motions that all particles have, okay, we have, this is just review. So what types of motions do particles have? Alright, they vibrate, they translate, and they rotate. Now, we said we'd talk about this during the gas laws and our next unit, which is on solids, liquids, and gases. So when we did this the other day, you guys told me, and I said you were right, beside vibrational, all right, vibrational, what types of materials vibrate?
Phones. So
Solids.
metals. So
All
metals.
right, solids can only vibrate. Now, liquids and gases could also vibrate, but solids can only vibrate. They cannot do rotational or translational motion. Now, for translational, all right, that could be liquids or gases. And for rotational, that could also be for liquids and gases. Okay? But solids can only vibrate. They cannot translate inside of a solid, and they cannot rotate because they're in fixed positions. And we'll talk about that down the road when we get there.
So liquids and gases can vibrate as well.
Yes, they can also vibrate. Now, if you've taken one of Mr. Owl's classes, you probably talked about when motion stops. Okay? Motion stops at a temperature called absolute zero. All right? Does anybody know what absolute zero is defined as?
Coldest anything can be,
Well, yes, but it has a number.
0.
Zero what?
Kelvin.
0.
Zero Kelvin. Okay? Absolute zero. Absolute zero is 0 Kelvin. Okay? That's the definition of 0 Kelvin. All right? Now, at 0 Kelvin, all motion stops. Now, to give you an idea of how cold that is, most of you think that 0 degrees is cold, and we don't get to 0 degrees here in North Carolina.
I think
Alright.
40
Isn't it like really hard to reach that point?
Now, 0 Kelvin right now is a theoretical. We've not gotten there. All right, it's negative 273 degrees Celsius or negative 457 degrees Fahrenheit.
That's
Yeah.
dead.
It's unreachable.
Right now, it's not been reachable. It's just a theoretical value.
And it's
Now,
that you'd be dead, right?
we'd long be dead.
Okay.
All right, life, plant life, none of that is sustainable at absolute zero. All motion would stop.
You walk in.
If you've watched something like Bill Nye Science Guy, you've watched them put a ball, a banana, something in liquid nitrogen, liquid oxygen, and you watch them pull it out and it's hard, or you watch them shatter something, that's not at absolute zero, okay? It's just extremely cold. So you're talking about being colder than that.
You're talking
All right.
about walking in and you are.
Now, motion stopping. I always use this example. So when you're dead, lying in the casket, are your particles still moving?
A little bit. Yeah.
They are moving. Now, if you weren't,
Are dead though. I don't get why they move.
if the particles inside of your body were not moving to some extent, would you decay beyond death?
No.
No. They could dig you up in 20 years, and your body would look as pristine after you died as you would 20 years down the road. Your particles have to move in order for your body to do what?
Look
To decompose, to decay. Okay? If those particles don't move in some fashion, your body cannot decay. Now, your hair is not going to grow. You are not going to walk and come back from the dead. But on a cellular level, your body is going to go through the process of decaying and turning into dust. Okay? Now, you will fossilize over time.
What about mummified?
You have to be mummified to become a mummy. Now, we already wrote that. You don't need it. We already wrote it. Now, the only reason that's still in my slide presentation after we've written it, why do you suppose that's there?
It's really important.
It is, but what do you suppose happens on the test? It is a question, and what do you think people pick?
Solids.
They don't pick solids. They pick the answer that has what?
All liquids.
Liquids and what?
Gases.
Gases. They usually choose the one that's got liquids and gases in it and no solids. All right. Skip all the way down to what is an ideal gas. All right. So we're going to study ideal gases. Now, an ideal gas is a gas that obeys all 5 assumptions of kinetic molecular theory. All right. It obeys all 5 assumptions of kinetic molecular theory. So, what are we going to have to do to obey all 5 assumptions of kinetic molecular theory? Well, there are 5 parts, and it's not very complex. I will tell you an ideal gas is a made-up gas. Okay, it's not real. All right, we're a first-year class, so we're trying to simplify our calculations. However, it's not hard to have an ideal gas. We just have to choose some conditions to make it easier to calculate.
It's real.
It's not that it's not real. It's just we choose certain conditions to make it easier for us to calculate. Okay? So, everybody caught up?
Yeah.
So, number 1, we're going to choose a gas that consists of a large number of tiny particles. Well, how do we choose a large number of particles? Well, this is easy. We're going to choose something like, so next to number 1, after you write that, I might choose 1 mole of particles to calculate with. Well, what do we know about 1 mole? How many particles is that?
6.022 times 10 to the power.
Now, is that a lot of particles?
Yes.
Yeah, that's a whole lot of particles. That's not unrealistic. That's pretty easy for us to do. So we're not going to calculate gas laws with a few particles. We're going to limit ourselves in a first-year class to a large number of particles. So even if we pick half a mole or a quarter of a mole, that's still a huge number of particles. So it's not hard for us to stick to something that would be considered ideal. Okay? We're not going to look at gas laws that have 4 particles. Does that make sense?
Yes.
Okay.
Is that an example of one?
That should go with number 1. That's an example of how we're going to have a large number of particles. We're going to use a large number, like 1 mole or 2 moles. All right, number 2. We're going to assume that all the gases are in constant motion and they move in straight lines. That's not hard to assume. Walk down the main hall here. Most people do that. How many times have you been bumped on the main hall?
Sorry for the interruption. I need to make an announcement. If we have any students who attend DCCC classes, those classes, day classes, have been canceled for today.
Okay, gases generally don't stop and ask each other to move out of the way or say, excuse me. All right, number 3 is a new vocabulary word for you.
This is a lot of conditions.
Yes, they are.
This ain't never gonna happen.
All right, all collisions are elastic. All right, elastic is a new vocabulary word for us.
Stretchy.
That's not the one that we're going to use. That's the one that y'all already know. Elastic means that there's no net loss of kinetic energy. Every bit of it is transferred. Now, in reality, is it all transferred?
Heck no.
No, some of it's gonna be lost as heat. Okay? Now, we're not gonna calculate what's lost as heat. This is a first year class.
There's no way that can happen.
Correct. But we're not calculating what's lost as heat.
This is so wet.
Ms. Wall, what is the last meeting again?
Huh?
And
No,
it's
I
right
have
there.
lost.
It's the next sentence.
Oh,
That's it.
Elastic means there's no net loss of kinetic energy. It's transfer.
That's.
The elastic collision means there's no net loss of kinetic energy. All of the energy is transferred.
Anybody got any allergy pills?
You wait, want something? You didn't have a little medicine bag.
Cause no, I
You just be
mean,
dying.
Ms. Wall, were you at the assembly thing?
No, I wasn't. I don't have, well, I have a club with Mr. Butts, but I'm sort of useless at robotics, so he told me last time I didn't have to come, so I didn't go this time either. All right, number 4. There are no attractive or repulsive forces. Now, what did we learn in the last unit about attractive or repulsive forces? Well, we're going to pick the weakest of them. So what are the weakest molecules we can use? Non-polar molecules. Does anybody remember which force we said non-polar molecules went with?
The London.
That's right. London dispersion forces are non-polar molecules. So we're going to pick non-polar molecules. So when we calculate, we're going to use a lot of diatomic molecules. So those of you who have forgotten your diatomics, you're going to get eaten up by those in the math calculations because you're going to lose points if you can't remember which molecules are diatomic because we're going to use a lot of diatomics. You're going to have to remember how to write carbon dioxide. Carbon
CO2.
dioxide, very good, is non-polar. So we use it a lot. Okay, things that are non-polar will pop up a lot. All right, and the last thing.
Can you read that? Because I can't.
Yep, the average kinetic energy.
Hold on. Okay.
The average kinetic energy of the particles depends on temperature. And that makes sense. The higher the temperature, the faster the particles do what? Move. If I heat the particles up, they do what? They move faster. If I lower the temperature, they do what?
Lay down.
They move slower.
Yeah, cause you know when people are cold, they hunch together too, and then they're supposed to atoms or whatever we're talking about.
Well, that's what my check, but it's hot. I should don't run.
I don't run on hot or cold.
When it's hot, I'm in my bed. Yeah. That's like.
Oh, brain pop?
Yeah, brain pop.
Probably so. We used to have brain pop when it was like $500 to $600 a year for the subscription.
$500 to $600.
Now it's multiple thousands a year.
Who would pay for a brain? Absolutely not.
Oh yeah.
I thought that was free.
No.
Call it academy.
They're out of their mind.
Yeah. Well, that's why we don't have it anymore. We won't pay for it.
Who would pay for that BS?
I'm talking like they're talking to kindergartners anyway.
I'm making animation at home.
Yeah.
That is insane.
I love different physical science. Not so much chemistry, but physical science was great.
That is a lot of money.
Not for that. Alright, moving on. So what conditions will we have in our word problems that will give us an ideal gas? Alright, I just gave you one of them in the description that we were doing for kinetic molecular theory.
Isn't it all of those that we just did?
Yeah, but how are we going to get that? How are we going to keep them far apart so they don't attract?
Let scientists do it.
No, we're going to do it. So what conditions in our math problems can I give you so they don't attract one another?
We don't know. Multiply.
What kind of temperature could I give you?
Absolute zero.
It's too what? High temperature. Okay. I don't want them to attract, so do I want them close together or far apart?
Far apart.
So what kind of pressure pressure do I want?
A lot.
A high pressure puts them what?
Low pressure.
Close together, so I don't want a high pressure, I want a what? A low pressure, so a high temperature, a low pressure, and what did I say about the molecules in 1 through 5?
No, it's right.
What about the no attraction?
They need to have
What?
energy.
Choice? Non-polar. Okay? So, we want non-polar molecules. We want them to be non-polar, so they don't attract. Now, aside from the fact you don't want them to attract, how can you keep them from attracting?
Hold them apart.
You want them to stay far apart. So that's the point of the high temperature. Okay? The high temperature and the low pressure keep them far apart. Okay? You keep them moving, and the low pressure keeps them from getting close together. All right? It keeps them far apart. Now,
What does the non-polar thing do?
again, nonpolar keeps them from attracting.
Oh.
Nonpolar, all right, is the weakest attractive force. Okay, because that was your LDF, your London dispersion force. That was the weakest one we had. Okay, we don't have anything weaker than LDF.
What is ideal gas?
That was what a kinetic molecular theory was. It obeys all 5 assumptions of kinetic molecular theory. I don't know what to tell you about that. All right, are we caught up?
No.
So, now, in reality, we don't have ideal gases, right? So the flip side of an ideal gas is a real gas. So a real gas is a gas that doesn't obey those 5 assumptions, and they exist in nature. Now, we're a first-year class. We're going to calculate ideal gases, not real gases. We don't have the skills yet to calculate real gases. For those of you who have to take multiple levels of chemistry, you will eventually have to calculate a real gas, possible.
What are we calculating?
Their pressure, their temperature, their volumes, their moles, their grams. You're going to have lots of experience with calculating for an ideal gas over the next week and a half.
I'm failing already.
No, you're not. Most of you are going to like this because it's easy, with
Really?
the exception of Annabelle. Maybe 2 more people. Okay. Dylan won't be a fan because he doesn't like the math. Okay. He's like the last 4 weeks. All right.
Sorry, I just didn't see you at first.
Now, examples of ideal gases that I already told you about were the diatomics. So we're going to use lots of diatomics. Now, I only listed 5 of them because they were our gases that were diatomics. I didn't include bromine because bromine's in what state?
Liquid.
Liquid.
That's
And
CO2.
iodine is a what?
Gas. Chlorine.
Iodine is what over there?
Noble gas.
It's a solid.
Hey, can you read this?
Cl2, O2, F2, H2, and N2. Say what?
Oh my god.
It's just the Hector now owns 5 clear.
We're gonna get to these notes then. Right. How much more we got left in the wall?
The clock right there.
We go we leave at 12, right?
Yep.
20 minutes.
4 slides.
Okay, we don't do it. We can do it.
5 minutes.
We can do it.
Just right.
Wait.
It's doable.
That's what we're trying to do.
12.
Okay, everybody, thank you that you got in here.
Hey, yo, Nelly. Shut up. You really told me.
Go ahead.
All right.
Just let
Alright.
the screen down so we can just write it all.
Nope. Then we just have a bunch of people talking. So, 5 properties of gases. All right. All gases have the ability to expand. They have the ability to fill their container. If you put a gas in a container, it does not stay at the bottom of the container. It will expand from the bottom all the way to the top. Huh? No, I don't have a gas I can test it with.
Wait, you talking about all of
Okay.
the items
Now,
and the real?
if you think about a balloon, we could do it with that, but I don't have extra balloons. I'm going to just hand everybody in the room.
Is this ideal and real?
This would be for you.
How many is there? 3 to 5.
Five. The numbers at the top.
Can't count.
Now, the next one has a very technical definition.
No, that's long. You don't put it once.
It's not long.
Squish.
Okay? Gases are compressible. You can squish them into a smaller space. Now, at some point in your science background, somebody should have,
Albert Einstein.
nope, probably drawn for you a picture that represented a gas, and they drew the particles, and they drew them with lots of space in between. Okay? And because there is lots of space, all right, the particles can be pushed together. Now, even if you have something like cork, I often get people who say it's small. Cork is a solid and it can be squished. Yes, it can, but what's cork filled with?
Air.
Air holes. Like the pieces of wood that are in tops of wine bottles.
Cork bar.
Here,
Cork
get up.
bar.
Oh.
This.
Okay?
Where'd you get that? Where'd you get that?
I drank a bunch of wine.
We know this ball. Look at you. Get one.
She said, look. You look stressed. That's all you.
I need to drink more.
Hey, I need some more. Hello. This is why you share. It is.
We know what kind it is.
Yeah, it is.
Some people just drink it out of the bag.
Yeah, some of them you can drink it.
These were really, really small bottles of wine.
This is a shot of wine.
Is that a
A shot of wine, that's wet.
Those are for test tubes and beakers, flasks, people. They're not for wine bottles. You order from a science company.
Miss Wall, you know you got one in the can.
All right? Now put my cork back.
Why you taking vodka shots now?
I have a liver disease. I very rarely drink.
So where'd you get all these corks from?
I just told you that we're ordered from a science company.
Oh, I thought you got
Yeah,
these.
yeah.
They're for test tubes.
Not for these.
They are bottles from where you've been using.
Therefore,
Oh my gosh, these are all really small.
I told you that.
Colored.
Now, mass and volume. When you think about a density for a gas, what do you have more of? More mass or more volume? What's bigger?
What are you talking about?
Think about your density formula.
Mass, because it's mass over volume, so mass.
Okay, think about a gas. What's going to be bigger, the mass or the
The
volume?
volume because it's below it.
All right. So this is going to be a small number, all right? And this will be a large number. I need to write that in a different color. No way Chris could see that. He even zoomed in on his phone.
Is D equals M over? Do we need that now? Or like?
No, I'm just explaining something. So when you think about density, all right, because a gas is going to have a really small mass and a volume is going to be a really large number, what's going to happen in math class if you divide a small number by a large number?
You're gonna get a decimal.
You're going to get a decimal number. You're going to get a really small number, okay? That's why the density of a gas is really small, because you have a small mass and you have a very large volume. Okay? Number 4, fluidity. Fluidity is the ability to flow. Molecules can move around.
Does that mean it can conduct?
Huh?
Does that mean it can conduct?
Not necessarily, because we're not talking specifically about electrons and their ability to flow or move. It's not a bad connection to make though. All right. So, which states of matter do you think will be able to flow? Thinking about solids, liquids, and gases. Liquids will also have the ability to flow.
Gas can.
Gas can too. The gases are the ones we're talking about. All right. I just want you to jump ahead. Now, the last property is diffusion. All right, diffusion is the spontaneous mixing of 2 or more materials. This is why teachers get bent out of shape when students pass gas. Okay, notice it says the spontaneous mixing, meaning, can you stop it?
No.
It happens all on its own. If Annabelle passes gas up here in this area, and I'm just picking on Annabelle because she's standing beside me. All right, if she's over here, it doesn't stay in this area. It will spontaneously mix throughout the room.
Y'all all
Okay.
smelling it too.
It's the same reason I get bent out of shape with my girls when they spend or spread stinky lotion or perfume all over themselves. Okay, or my daughter when she uses nail polish remover in her bedroom, and I'm like, really? Go outside with that stuff.
Who went outside to clean up the
I hate the smell of that stuff.
But there's some stuff
I don't care.
Open
You gotta find I can't stand the smell.
Next slide, we got 2 minutes.
Okay? Say what? Oh yeah, I hate it. Every now and then she'll harass me to within an inch of my life to have a pedicure, whether it's not me. I will do it about 3 times a year, and that's about it.
You feel great. So all you like your dog rubbed on?
Huh?
You feel like your dog's done rubbed?
I can't stand the smell of the nail salon. It's not that. I don't mind having the pedicure. It's the smell. I mean, I feel like I need to go to an oxygen mask.
So you would go to like our
If it doesn't smell, yes.
Oh my God.
I just can't stand the smell. Alright, so
Mine does.
in looking at those 4 quantities we're going to use, there's only one that we haven't learned to calculate with. What's the one we haven't learned to calculate with?
Pressure.
Pressure.
Pressure. That's the one we have to finish today with. We've done volume. We've done temperature. We've done mass moles. But we have not talked about pressure. Pressure is the only one we have not done. And the downside is there are 5 units of pressure you have to know how to use.
Lovely.
You are full of complaints today. You should stay home tomorrow.
Oh, girl, I wish I could, but we out Friday.
Okay.
I can't miss no more.
I was just thinking you would have less to complain about if you stayed home.
No.
Now, pressure is defined as force per unit of surface area. I'm pretty sure it's optional. All right, pressure is defined as force per unit of surface area.
It's not mandatory, but it's highly recommended. I'm just doing it. I think I really don't want to go though.
Space go.
It's gonna be beneficial.
I'm gonna freaking die.
It's not for a grade.
I don't understand what we had to do.
But it's gonna help your grade.
Would you want to come on Saturday? No.
I'm not Saturday school, no.
I don't think I'm gonna have to go there because I still got my 4 absent card for like.
I'm gonna tell her that. My desk is gonna be.
All right, we caught up? So, we need to talk about how pressure and surface area are related to each other. All right.
Saturday?
There we go. How are pressure and surface area related to each other?
Well, you have more pressure and more area, right?
Okay. Now, this one's an easy one to remember. Or at least I think it is.
About all these units. Mention that every time. It's easy.
And the people like me.
Stand up after you write it down, and I'll show you how to remember.
Stand up.
Yep. Everybody, you can stand up. It's not hard. Everybody, stand up. Stretch out for a
Well, can I
second.
say that
No, don't stand on the stool. I don't want to explain to anybody why you fell off the floor. All right, tell me this. What part of you is your surface area as you're standing? Your feet. Okay? So what is our pressure? What creates our pressure? Our weight, because gravity's pulling us down. Okay? So our feet is our surface area. Our pressure is our weight pulling us down. All right? If we want to change our surface area, what do we do?
Do a handstand.
Do this. I'm gonna do it.
Lay down.
How about we just stand on our toes like the girls did when they went to the prom before they ditched their shoes, I'm sure. All right? So stand on your toes for a minute.
Handstand until I see it.
All right? What do we do to our surface area?
You decreased it.
We decreased our surface area. So if you stand on your toes for a few minutes, what happens to your pressure?
Your calf gets
More.
Does your feet start to hurt?
Yes, it increases.
Your pressure will increase. Okay, your surface area decreased. Your pressure does what? It increases. So what's decrease and increase?
They're inversely proportional.
They're inversely proportional. All right, so write it down. Write it down, or you'll be watching some video. We're getting close.
It's inversely proportional.
Yep, it's inversely proportional.
Hey, we have almost 5 minutes. Shut up.
All right, it's inversely proportional.
We got 2 times.
All right, so as surface area increases, pressure decreases.
Just like trying.
Oh my gosh.
Now we need to talk about the 5 units and what they are and how to calculate with them.
Go ahead, switch if you don't get time.
We've
You
got
got on the board, we good.
8 minutes.
8 minutes.
I mean,
All right, everybody got it?
yeah. That's okay.
All right, it's inversely proportional.
What is that?
All right, these are our 5 pressure units.
Oh no.
All right, ATM is called atmospheres.
At the moment.
MMHG is called millimeters of mercury. Torr is called Torricelli. PA is called Pascal.
Papa.
And KPA is called kilopascal.
You sure ATM ain't no saying big
ATM is atmospheres.
Is this a lot?
Torr sounds like a
Slide.
pasta.
Other than you haven't had to use them by tomorrow.
Right tomorrow, we have a clear.
Possibly.
We have a list.
Possibly.
How many questions? How many
Depends on what all you quiz.
What would it be on
Is
me?
it gonna be like
What we just
definition
did
stuff?
today.
It's like definition stuff. We didn't
Possibly.
learn it in
Right,
math.
I can get past some of this. We're getting ready to do past.
No, because no, we're not.
Oh, yes, I do.
No.
Annabelle doesn't get a vote.
Yes, Annabelle does, and Annabelle and the rest of the class votes no on math stuff. Correct?
Correct.
Correct. Aye?
Aye.
Thank you.
It's not a democracy,
It
it's a
is.
dictatorship.
No. This ain't-
Perhaps y'all should study up on that again. Alright. So, how do you convert?
Use it wrong. Yes.
So, an atmosphere is equal to 760 millimeters of mercury. Yes. Now, the top 3 are on your reference table. So those of you who are moaning, the top 3 are on your reference table. Okay?
So just learn the left.
The bottom one is not on your reference table.
Wait, is this the last slide?
Other than us practicing it, you showing you one or
I
two.
don't think you want us to practice.
So what? Only for the people like Annabelle who are like, I don't know how to do this on the plan. All
I
right.
talk like that.
So 1 through 3 are on the reference table. 4 is not. Now, would I be so vicious as to give you the last one?
Yes.
I can guarantee you it's on the quiz.
Bro, just move the decimal. That's so stupid.
Now you can convert it from KPA to PA every day of the week.
Ms. Wall, are you sure you weren't born in North Korea?
I'll never tell.
I'm
I might be related to Kim Jong. You never know.
Or you might be related to him, so you what? Stepmom?
You know, my last name's Holtzlander.
Look, ain't that a problem?
We need to practice.
No.
I'm good. I can just assign homework.
Girl, you can assign it. I'm just gonna search up the answers, call it quits.
Yeah, we need to go home and study, so let's
Practice.
Why would you turn it back, you idiot?
I can't write on it, so all you have is a white screen.
Me and Akaya fight like sisters.
There you go.
We do. Yeah. It's bad.
That's bad.
All right. Let's say that this is your question tomorrow.
No. Wait, it's the same thing. No, it's not.
What is this? I know we're not converting. I know we're not converting.
So you
All right,
just
what goes on the bottom?
the
MMHG.
and it's need a 1. Please get a 1.
All right. Those of you who are talking, stop and pay attention. What are we putting on the top?
The whatever you want. Whatever you want. Like what you were trying
You
to
can
get
put
to.
KPA on the top, which is what I would put on top.
What else would you put up there?
A lot of people think you have to go through ATM.
No.
No. No.
Okay?
Absolutely not.
Why would you do that? Why would you put so much extra effort into it when you
Because
don't need
they
to?
do it like you do, moles.
Just one.
So just a one step.
Okay, maybe I would do that, but
I definitely wouldn't.
Okay, so what do you do with
Because they do the same thing you do with moles. Now, moles, can it be something other than a 1?
No. Yes.
Yeah.
Mole ratio.
With mole ratios. Is KPA and MMHG, would you stop turning this?
Girl, that is unnecessary.
All right? When you look at this, is ATM ever going to have a number other than 1?
no.
No. So you don't have to go through ATMs. You can just look there. MMHG has what? 760. KPA has what? 101.325.
This don't make.
And then convert.
That's stupid.
Where
Where did you get all these numbers from?
When you look here, what number is in front of KPA?
That-
101.325. So I put that in front of KPA.
And it
What number is
gives
in
you
front of MMHG?
and it gives you the
760.
385.
I only put a 1 if I have ATM on the line. I don't have ATM on the line, I'm not using it.
I get it.
Yes. What? As long as you are within 1, no. If you're not within 1, yes.
What's the answer?
I don't know.
Yeah.
Okay.
This is dumb. I'm sorry, Karen. I got in your
Are we
way.
getting a worksheet?
Should be going for a run.
I'm driving the bus.